All right, let's get this started. This is the TLS working group session, just the second of our 2 sessions this week. Can I get the clicker? This session is a little different because all of the drafts that we're going to talk about today are not working group drafts, so we're going to try to use the clock a little bit so the speakers can try to self-regulate themselves, and if you are in the queue, please try to keep succinct. All right, and with that note, you can start the timer if you want. Oh, hey, I was trying to figure out what that was, yo. Fair enough, yeah. This is the note well. You probably, hopefully, have seen this by now. This is the rules of policies and procedures. This is the rules, policies, and procedures. Hopefully, you've seen this by now. This is the note really well. This is about treating other with respect. Meeting tips. If you're going to we're going to use the queue and the thing. So if you're gonna speak at the microphone, you need to get in the queue, so we don't have queue jumpers and all that good stuff. That was Tuesday's agenda. This is Wednesday's agenda. A lot of individual drafts, basically. I was a little bit. I think a lot of people asked for 5 minutes, and I was like, you can't do that in 5 minutes. So, but I'm hoping that we'll be able to get through all of these again. I guess the only thing I want to add is that from the stuff that we did on Tuesday is that I know that there's a lot of people take vacations. So please make sure to contribute on the mailing list before you disappear. We're going to have a working group adoption call for the PAIC draft, and we're going to do a working group last call for the legacy RSA BKCS version 1.5 signatures for TLS 1.3, and there is an SLH DSA working group adoption call currently ongoing. So with that, I'll hand over the clicker to Yaroslav. So take it back. Okay. Okay. Oh, you're doing it. Look at that. Awesome.
Good afternoon. It's Yaroslav, and I would like to start with workload identifier scope hint. Now, essentially, this is a successor, in a way, spiritual successor of MTLS flag that builds up on that original idea, but expands use cases. MTLS is great. MTLS is certain unofficial language for mutual TLS or mutually authenticated TLS when both client and server present their certificates. So it's great for, in many cases, for bots. It's really good for workloads when two workloads communicate to each other without intermediaries. Then MTLS or certificate-based authentication for both workloads is very attractive for certain proxies and in many OT, IoT environments. As we all know, it's really not that great for user-facing web browsers because of UI issues, smart cards complexities, and what have you. Now, the challenge that many are facing, there is no easy way to just enable mutual TLS because when many user agents, especially web browser, receive unexpected certificate requests, they freak out. They give to user some dodgy looking prompt asking insert your smart card or just stop working because they don't expect certificate request. So what many people end up doing is creating a separate endpoint that would be just for MTLS. I think a good example is OpenAI recently launched their API with MTLS authentication, and they created a separate endpoint just because enabling certificate request on the main endpoint would be disruptive. Now, one other building block I'd like to share is WIMSI workload identifier. So in WIMSI working group for a while, we've been working on standardizing workload identifier. It's been part of other work. Perhaps we will be moving that into a separate document. Long story short, it's an absolute URI that consists of 3 parts. There is scheme. There is one well-defined scheme that's called SPIFFY. There is trust domain that lives in authority field, and then there is scheme-specific path that could potentially be anything. There are all sorts of security limitations on workload identifier in terms of lengths, not using non-ASCII characters, and so on. Now, the first 2 parts, scheme and authority or trust domain, could be grouped together as workload identifier scope. So telling you where workload identifier is potentially coming from and what's the trust domain of that workload identifier. So the proposal is to introduce an extension in TLS client hello that could contain a list of workload identifier scopes that would indicate that client promises not to freak out from certificate request, that it promises to process it correctly, and that client can provide certificate for any of the listed workload identifier scopes. Potentially, server can use the hint in other implementation specific ways. So for example, they can see that, that is a host workload, source workload that I don't want to talk to at all, and terminate that connection before going any further. We already have Dennis in the queue. Dennis?
Get to the end of the slide if you'd like to. You can wait. Do you want to get to the end of the slide?
Yeah, sure. Okay, thanks. Right. Privacy concerns about workloads. So if your workloads are particularly shy and you don't want to disclose their trust identifier in client, the trust domain in client hello that is carried in the clear, you could potentially do empty list. That still indicates that you're happy to do certificate, to respond to certificate request, but you don't disclose who you are. Essentially, that becomes MTLS flag that was proposed previously. You certainly can use ECH as another way to hide from casual observer your trust domain, or you could combine these approaches. You could do empty list in outer client hello, and inside inner client hello, you could use your list of workload identifiers. And that is the proposal. Any questions, comments, objections?
Dennis Jackson, Mozilla. So if you go back just maybe 2 slides to, yeah. So here, I think there's a difficult engineering question. Like first bullet point here is basically, we have some strings that we're going to put into the client hello. And then third bullet point is, we're going to use them to do things that are kind of application specific. And this is really like the shape and structure of a user agent, right? Which I think, if we're one lesson from HTTP, was like not the best move. Much preferable is to have like very specific things that are negotiated in like a way that's meaningful for everybody. And I sort of hear you with the pains around client certificates and prompting for them. But I would think that there's a way to do this right, which is very meaningful flags that indicate, for example, the server's asking you for a client certificate, but don't prompt the user. Like there's an extension flag set on the certificate request saying, don't bother the user about this detail. Or, for example, the previous flags proposal, making it clear that this client is fully automated and will never challenge the user. So you can ask away because it's going to do the right thing. And those are much more meaningful things that are like well-defined and can be like interrupted and tested, as opposed to like application specific, send this string to trigger this very specific behavior, which, very quickly people end up emulating, copying poorly, and like, it becomes a bit of a mess. And then the actual spiffy stuff just goes into the client cert, which is, where you have the signature anyway.
So, yeah, I mean, the strings are really well defined, and in SPIFFE and in WIMSI specification, again, they have a certain length limit and certain acceptable list of characters. There are different workloads coming from different trust domains. I don't see here necessarily trust domain becoming a user agent. Trust domains means where you come from vaguely, and user agent means more who you are or what software you're using. They are very different things. And then again, as I mentioned, if your use case doesn't, you don't want to disclose this information, you can send an empty list.
Yeah, I think it's this third bullet point, which really to me means what a user agent does. It's something that's used for information-specific negotiation. So I think if there's a way to get rid of that, I think the shape of this thing looks a lot better. But I think it's that sentence that.
So you mean that we want TLS APIs to ensure that they don't disclose this to the
No,
application?
I just mean like there needs to be a way for the draft to be well formed without needing to just sort of say, good luck with it. Do what you want.
Okay.
Okay. Just again, keep it succinct. Thanks.
So this is probably a stupid question, but why wouldn't you just using ALPN or something that exists already work?
Sorry, could you repeat that?
Why would just using something that exists already like ALPN, why would that not work?
ALPN, no, that would not work because that's not what it is for. You cannot use AL. You cannot use AL. So first of all, here it's useful to separate application layer protocol from am I doing authentication or not. They are two very different things. You can do that with any ALPN. You still want to signal ALPN.
Right. Okay. I mean, it seems like it would work even if it's a bad thing to do.
You could create a separate tree of ALPNs with MTLS enabled, but that's not the most efficient approach, I would imagine.
Is it my turn?
Chris Patton.
Yeah, I just wanted to say I support this work. I think this is an improvement over request MTLS, specifically because of something that has been absent from the discussion. What the client is effectively doing is like indicating which PKI it's part of, and this avoids some problems that we'd have to address if we were just indicating I have a certificate. So I think to me that's a plus for this draft. I think using it in tandem with encrypted client hello is a perfectly reasonable answer to I think any privacy concerns that might come up for use cases.
Thank you, Chris.
Hi, I'm Arndt Schwenkruster. I'm from the WIMSI working group, and I want to also give a +1 on this work, or like at least on the problem, because it would help developers immensely if they don't have to like host the applications on 2 ports, route the traffic, etc., just to be able to authenticate clients via certificates, while also allowing them to do some higher level authentication, for example, with a job token.
Thanks, Arndt.
Victor?
Sure. Is this intended to subsume the work that was done in DANS to ask for MTLS? And can we signal, the client indicating where its TLSA records might be found once the certificate's requested?
Sorry, I'm not sure if I fully understood.
I think we're going to have to.
There's a DANS working group, and there was it's about using DANE in clients. And one of the things that's useful there is, of course, to have the server ask for a certificate so it can be presented, because otherwise it's not going to happen at all. And of course, the client might want the server to look up its TLSA records, and maybe that can be signaled early by signaling that the client's domain where its TLSA records will be found as part of the please ask for my certificate request. Indicate that it's a TLSA based client, and here's the domain to go fetch the cert from.
All right. I did lock the queue, Ecker. I'm hoping we can take this to the list.
I think I probably pressed the button before you did that, but okay.
Okay. Sorry. I'm sorry. We just it's packed today. All right. Let's go on to the next one. So, get that away.
Frankly, I'm not certain I understand what the problem is, because the whole purpose of MTLS was supposed to enforce both user and server authentication. That's why it's mutual. So making it conditional, I do not understand the purpose. Normal TLS is conditional. You authenticate.
Sorry, Yuri. We're gonna take it to the list. Okay. I think we got the point.
Okay, and now to something else. TLS 1.3 certificate update. So Tiro and I will be presenting this together. Certificates expire for a reason. not just to create havoc and entertain engineers with infrastructure outages when they forget to rotate certificates, but they also solve a number of security challenges. So private key could be compromised in a way that is not always known. So rotation of certificate enforces, it reduces the risk of compromise of private key. As was discussed on the list, identity of communicating party could be effectively revoked. So server could lose its role and not necessarily shut down in time, or an employee who is performing certificate-based authentication could lose their job but still be in a possession of certificate and keep the session up and running, and other unfortunate events could happen that essentially invalidate identity or context associated with that identity. And as a result, authorization context may change. There is a good recent practice of reducing lifetime of certificates. This is just an indicative example. I'm sure there are many mistakes on these diagrams. These are evolution of CA browser forum requirements that went from 60 months down to, is going down to 47 days. And I'm sure other standard bodies are also reducing recommended lifetimes of certificates. And there are some use cases that benefit even from shorter certificates. Even on Let's Encrypt, you can today request a certificate that would be valid for 160 hours. Obviously, there are use cases for that. TLS implementations do not look fondly at expired certificates. They give all sorts of errors. In some cases, these errors are not user bypassable, but they look as bad as this is invalid certificate or this is incorrect name. So expired certificate generally treated by user agents in exact same way as all other certificate errors. Now, the idea behind this work is that expired certificate present similar, probably the same as two-strong word, similar level of risk to already established connections. So when we connect to something and certificate is expired, it's nearly as and we have a long-lasting session during which certificate has expired, it's nearly as bad. So options are do nothing, so authenticate only at the beginning and hope for the best. That's what most implementations do today. Another option is not to upgrade to TLS 1.3, keep using TLS or DTLS 1.2 that have re-authentication mechanism that is used. Obviously, that's not a valid option that we want to advertise. Signal new certificate on application layer. Now we have exported authenticators that we could leverage to signal new certificates, but that's really complex. As we have seen, HTTP working group has been working on secondary server certificates for many years and still working on that. And then there are some protocols that leverage or plan to leverage TLS or QUIC that just really hard or impossible at all to add certificate information on application layers such as BGP or IPFix. There is some work to get those protocols use TLS or QUIC. And then there is an option that was also discussed on the list to reconnect. Obviously, it's generally disruptive reconnection. Some of these risks could be mitigated or reduced, but when you have carrier signaling or when you have long-lasting VPN session, then migration could be difficult, and it also carries downsides similar to pre-1.3 negotiation because less secure cryptography could be negotiated during the reconnect. Bas, you have a question?
Please continue after you.
Oh, okay. And then this proposal is to implement certificate update on TLS layers so that TLS peers could signal when their certificate is renewed. So that would be applicable to use cases where we have sessions living longer than certificates. It was extraordinarily exotic a number of years back. Now it's very real. There are cases where sessions last for weeks and months. And again, there is a push to reduce a lifetime of certificates where reconnect is disruptive and consequences of compromise are very high. So there are two areas that we as co-authors see. One is long-lived site-to-site VPN tunnels, some of Musk use cases such as Connect IP, and then carrier signaling. Tiro, going to share something?
Yeah, thanks. Currently, we're working on securing HTTP for mobile networks, and my co-authors are presenting how to secure that in TLS in TSVWG. And one of the requirements for that is like we need long-lived connections, and we can't do make and break basically, right? I mean, we can't disrupt the connection and establish a new one. That was being proposed, but that was rejected. So we need a long-lived session where we want to periodically do key extended update and as well as basically check if the certificate is still valid. So to meet those two requirements, the later one we're currently relying on RFC 9261, which requires us to change the application layer, which we don't want to do, and this draft would help us to progress that work.
Right, so I probably don't want to go in limited amount of time in technical details, but the idea is to include extension and client hello that would contain optional exported authenticator that's then during the session could be used in new certificate update message that would send, authenticator request previously, and this is authenticator that would carry new certificate. We list number of very tight requirements for new certificates that they must not change anything in authorization context, that is subject as before, same extensions, same key algorithm and key length, same CA, so that is we don't generate any authorization event for the application. So essentially only validity and public key may change a card certificate renewal. And then peers could share additional authenticator requests after initial was consumed. So I see we have already quite a few people on the queue. Bas, go ahead.
I'm Bas from Cloudflare. So I think it sounds bad if a session outlives the lifetime of a certificate. It sounds bad, but what I would like to see is a concrete attack scenario where you have this long-lived connection and this certificate update actually prevents an attack, because I don't see one. So I think that's really necessary.
Right, so there are two concrete examples that I have. One is private key got stolen, got compromised, and nobody knew about it. So we didn't know that we've connected to the right TLS peers at the time when we have performed authentication. So when certificate expired and it was not renewed, we could terminate that session to mitigate this risk. With certificate update,
sorry, come again. The private key is stolen, right? But then during that time, the attacker can use the private key. But
so private key was stolen before session was established and nobody knew about it.
Yes.
So we established the session to wrong peer.
Yes.
Right, and that wrong peer will not be able to perform certificate update because they would not be able to obtain a fresh certificate. That's one example. Second example is when identity effectively expired, meaning we were connected to a server, that server lost its role but was not shut down, and but bad things could happen because of that, and when we didn't get certificate update in time.
Right, so I'm going to challenge the requirement here. You're deploying this into a system that has to be highly available and redundant, typically, which means that it needs to also be fault tolerant. It's been a long time since I've worked on the architecture of systems that interact with these sorts of networks, close to 15 years, but even at the time there, we spent a lot of time working on failover scenarios and whatnot, and I cannot believe that you are unable to do a failover once a week in these systems. That seems like a pretty unrealistic limit. And even then, I have some ideas that would potentially allow you to keep a connection available for a lot longer than that. I'm rejecting your loss of private key scenario. If you lost the private keys, I think some level of disruption is inevitable. And losing a connection is probably the least of the things that you need to worry about at that point. You probably will probably have to roll back a whole bunch of transactions and all sorts of other things. So in that event, I think you've got much bigger problems than trying to keep a connection around. But in the event that you just want to refresh the certificate because it may or may not have expired, applications can check the validity time of certificates anytime they like. They can I suggested the option of fetching a certificate using a certificate extension. For instance, you point to where you can get an update for that certificate. That would be possible if you retain the same key pair for things like this. But this level of disruption to TLS is, I just can't see it being justified by those use cases thus far.
Yeah, thanks, Martin. We tried basically whether it's possible to change the application itself so that they could go back and check it by themselves without having to do it at the TLS level, and that was rejected basically. So that's the reason we are back to this working group.
Andre Popov, Microsoft. So a few points here. So during the duration of a TLS connection, the certificate can become invalid for a variety of reasons, and expiration is just one of them, right? So there's the contents of your certificate store could change. So the certificate is no longer trusted. The certificate could have been revoked. There is, CRL came in and so on. I don't think it's the job of the TLS stack to keep track and make sure that the certificate remains valid on this system for the entire duration of the connection. If there is an application that needs this unusual functionality, an application can implement it. It's easy enough to query the certificate and continuously validate it if you want to throughout the entire duration, or do it as frequently as you like. The use cases that were presented where, where, for example, the server lost its identity, it's no longer the server you want to be connected to, and so on, they do not correlate with certificate expiration in any way. So I don't think the solution correlates to the problem that was presented. So, yeah.
If you just need to keep the underlying transport connection open, there are other ways to start a new TLS session over the existing connection. And I think using some mechanism like that, if we do have some requirement to keep the underlying session open, would be much simpler than modifying TLS itself.
Watson?
Hello, Watson Ladd, Akamai. I think I have some concerns that when you say you need to get a cert from the same authority, you might not be able to do that in some of the break cases. If, say, that authority was compromised, your new cert's going to have to be from somewhere else. And so I'm worried that this extension really only is useful with expiry. It's not really necessarily that useful in a revocation scenario.
All right, so I think it's pretty clear that we need to take this to the list for more discussion. Thank you very much. Thanks. I took that back. Stop those slides. These slides. Brendan.
Hello, can you hear me okay?
I can, yes. It's okay if I run them and I can just...
you just gave me slides.
You got it. Never mind. You can control it. Awesome.
Okay, so I'm presenting a draft called Reliable Transparency and Revocation Mechanisms that I worked on with Devin O'Brien and Dennis Jackson. So the problem this draft is trying to solve is that the security of the current CT ecosystem is based on these kind of flawed assumptions that log operators can be both perfect in the sense that they never have any real operational failures, and also independent in the sense that they can be trusted not to collude with each other. And both of those assumptions have been broken in practice. So log operators pretty regularly encounter different failure scenarios. And also they're not really that independent because there tends to be a lot of overlap in the different cloud providers that people use. Employees of these companies tend to move around. So you might have one person who has had access to several different, log setups. And also the business relationships are not always super clear, where a lot of times log operators are private companies, so the ownership structure is not clear and they can be bought and sold pretty quickly. The second problem is that monitoring CT is very unrealistic for quote unquote normal people because it requires downloading every certificate. So that's tens of terabytes of data usually that you have to download. And even if you do download all of that data and you find a misissued certificate, there's not really a resolution because there's not a consistent way to do revocation in TLS. So the main solution that the draft is based on is called key transparency. which is a protocol that we're working on in the keytrans working group. If you think of a normal transparency log kind of as like a giant stack of paper, where every time you add something new to it, you just kind of like pop it on top. The consequence of that is that whenever you want to find something in this giant stack of paper, you have to dig through the whole thing. By comparison, a key transparency log is more like a filing cabinet in the sense that it's organized. So, number one, that makes it very easy to find things that you care about. So you can just like go to one of these filing cabinet drawers, you can pull it open, go get the file folder for example.com, and then all of the certificates for example.com are in there. So you don't have to go through the whole system to find just the certificates you care about. And also, that if there was a certificate for example.com, it would be definitely in that file folder. Yeah, key transparency generally makes it very efficient to work with these logs when the vast majority of users only care about a small subset of their own data. And so actually applying that to TLS, how does that work? The way that it works is the TLS server takes its certificate, it submits it to a transparency log. It says to the transparency log, hi, this is my certificate. I want to use the certificate for these domain names or IP addresses. And then the transparency log comes back and it says, sure, here's proof that, number one, I've logged the certificate for these names. So if you come to me and you try to look up the certificate for that name, you will find it there. And I can also prove to you that there is no revocation for this certificate. And then the TLS server basically in the TLS handshake just forwards that along to the TLS client, and the TLS client can do the same verification itself. So it can see, okay, the certificate is logged for these names that I'm verifying it for, and I can also see that there is no revocation for the certificate. So what's actually really exciting to me about this draft is the security model. So like I said originally, CT is based on the assumption that log operators are perfect and that they are independent. That's what we have here is the secure assuming no collusion. In this draft, clients actually have the ability to maintain state to basically remember, okay, I went and I talked to this server and it showed me this view of the transparency log, and then I went and I talked to this other server and it showed me this other view of the transparency log, and I can use my local state to see, okay, are those two views consistent? And if they're not consistent, is that proof of a fork? And if it is proof of a fork, then I can do something about that. I can either report it to the user, I can report it to my browser vendor or to the police or something. I don't know, I think that's really cool because it means that basically no matter how not perfect or how not independent transparency log operators are, if it actually translates into there being an attack on the TLS connection, then the client is secure from that and they have ways to detect that it happened and do something about it. The draft also supports revocation. The way that works is that a CA signs a statement saying the certificate is revoked now. It logs that in all of the transparency logs. And the consequence of that is that then when the TLS server tries to refresh its proof, it says, I would like to use the certificate. The transparency log can no longer do this second part where it proves that there's no revocation for the certificate because there is a revocation for the certificate. And the structure of the log wouldn't be able to produce that proof anymore. And so when I presented this draft before, a lot of times people will say, we don't need revocation because we already do short-lived certificates. And that is fair. We could remove revocation from the draft, but it would not significantly simplify it. And also the revocation that we get from this proposal is kind of really nice. So with short-lived certificates, the more you reduce the certificate lifetime, you always have this corresponding increase in how many certificates you need to issue, how many certificates need to be logged in CT. Whereas in this draft, longer-lived certificates can be revoked just as quickly as short-lived certificates, and they are less burden on logs. And also with short-lived certificates, there's kind of a lower bound to how short-lived the certificate can really be, because you have to renew the certificate before it expires again, and the CA is a single point of failure in that regard. So you wouldn't issue a certificate that's only valid for 2 minutes, because if your CA is down for more than 2 minutes, then your website goes down as well because you can't renew your certificate. Whereas in this proposal, maybe you could do like 2-minute revocation because there's automatic failover between transparency logs. So if one transparency log is down, then you can fail over to another one quite quickly. And I saw a question in chat, why is this being presented to the TLS working group? Because it's almost entirely a TLS extension. So actually, this part right here saying, sending the KT proof from the TLS client to the TLS server, that's the vast majority of the draft. But that's all of my slides. Let me know if you have any questions, if you want to hear more about this. Thanks.
I mean, I think that's confusing words on the page with actual work. Like the actual work is constructing an entirely new PKI based on this idea, and and not shoving in TLS. So I just don't think that's it's not. This isn't this isn't fundamentally like a TLS problem any more than CT. Like the problem of how to stuff the CT things in the TLS handshake was. To refer to Dave Benjamin's point, I agree that they're very different things. But fundamentally, they're both. Let us rewrite the existing web PKI in some way. And so we should only rewrite the existing web PKI once, I think. In any case, we shouldn't rewrite the existing web PKI at all in TLS.
Okay, Victor.
Perhaps something very similar. The current CT doesn't have the client really going out and talking to the logs at all, right? In this protocol, you haven't explained what the client is doing, but it sure sounds like the client is actively relying on the logs being, around in near real time and making judgments about, current responses from the log rather than data from the log at the time of certificate issuance. So this is a vast change in the model and it requires a lot of language to explain what's going on.
All right, so the flow here is not that TLS clients ever go and talk to the transparency log themselves. Everything is always filtered through the TLS server. So the TLS server goes and talks to the transparency log and then forwards that to the TLS client.
Okay, Felix.
Yeah, hi, thanks for the presentation. I've read the draft. I think it's an elegant solution to both the problems that you showcased. So I'd like to see this work move forward. I cannot judge at all where the best place is to do so, but I think it's a nice document.
Hi, yeah, thanks for the presentation. This is very complicated. There's quite, ooh, wow. Hello, microphone decided to fall over. That was interesting. There's quite a lot hidden in those little pictures with the arrows because there's 3 different kinds of proofs. I think each proof has a couple of variations on it. A whole new log structure that we have no experience running in the certificate, at certificate transparency scales. For CT logs, I think we went through 3 generations of the software, and there's actually a new generation of the protocol before we finally got something that can actually be operated. We're sort of proposing to increase the size of the proofs quite a bit because each name in the cert now needs its own sort of demonstration of the client that it's not just in the log, but also positioned correctly. So I worry that we're sort of proposing to bite off a little bit too much all at once. I think also some of the the problems to be solved here, the not very good auditability of CT and revocation and stuff, are certainly very much problems. But I think the reasons for those, and also certainly and the monitoring. Okay, I'll talk monitoring separately. I think the reasons for those problems aren't quite what this draft is targeting. The reason clients auditing has generally not worked in CT is that there's a privacy cost to going back and saying, hey, I saw this cert. I believe this draft solves it by having the clients phone home to the next time phone home to the server that they talk to, which works if you were going to talk to the server again, but otherwise you have to go and, when the user didn't want to go visit this website, go and visit it anyway, just to go and ping it and get the log. And then I think there's something in there about if you can't do that, then you must go report the information to a third party. I'm a little nervous about how that will go, and I suspect a better direction would be to reduce the amount of information that is leaked, and then sort of play around with that design instead. Revocation likewise is bound right now primarily by how fast we can get servers to update stuff. It's true that at some point the limit will be whether the logs can churn all their contents, and maybe by then we will need to think about different log structures. But we still need the servers to get fresh things, whether that's a certificate or something else. And that's the piece we're missing right now. And this draft doesn't actually change that. What it does do is cause those servers to need to talk to different parties. So we're now changing the server, like the deployment model for every web server on the internet to not just, oh, I need to go talk to my CA to go get some stuff, but then I need to go farm out to all the logs and fail over between them. Whereas the benefit of sort of tunneling things through the Acme pipe is that this is a communication channel that already exists and we just need to improve upon it. So I think probably like a more incremental approach might be a better way to like sort of solve these problems. I guess I didn't talk about monitoring. There's some cool work on the transparency side, on the CTU transparency ecosystem to like add a verifiable index that like probably should go work with them on because it's super cool. Like I don't know. I think both structure, like I guess it's a similar sort of structure, but I suspect there is, something to be done there that's sort of separate from the other stuff. Sorry, I babbled a lot.
Okay, Dennis, and we gotta be quick.
I'll be quick. Yeah, Dennis Jackson, Mozilla. Yeah, I think there's a lot here. I think, as Eka said, that this is probably too big for TLS in my opinion. But I think the plants mailing list and BOF that's going to be set up would be the perfect place to kind of feed this into. There's certainly like two big drafts and two big designs on the table there. And the sort of the nice thing about BOFs and charters is that you can figure out the problem state, the problem that you really want to work on.
Are you doing it?
Yes, take that slide control.
Right, thank you very much. I'm Osama, and it's, thank you. It's an update for those who were at the BOF, and for others, an update to what we presented in the last IETF meeting, such that if some of you were not here, you could have a chance at what we have done. So the idea basically is that we have defined the threat model under which we are working. And that namely includes standard TLS threat model, all the weaknesses, like if, for example, weak Diffie-Hellman and weak hashes and so on. So it's a standard which is used for any formal analysis. Long-term key of the server or the client, whichever is the attester, can be leaked. And then finally, the attestation key, that's the new thing compared to TLS, that the attestation key, which is used here, may be leaked, and that's also possible via attacks and practically shown via foreshadow, for instance. In addition to that, we believe that there are some assumptions that are not possible to be provided by the protocol itself, or at least are very hard to be provided by the protocol itself, and they have to come from the system level. And that's what I put it as part of the assumptions coming from the system rather than being provided by the protocol design. And we believe that is really hard to put inside the protocol itself, because a protocol, for instance, cannot ensure when the claims were generated and what the claims actually contain. So for them, it's just an abstract material which they just carry and put it over to the other party, to whether the client or whether the server, I'm sorry. So whoever is the tester, it's just a conveyance material for that. Secondly, like the verifying relying party, sorry, provisioned with the reference values, that before the start of the attestation protocol, it has to be already done. There is nothing that the protocol can actually do if the reference values were incorrect, meaning that if you were provided with hash values that you have to check for the binary, if they were already wrong, the protocol cannot actually do anything. If you were provided with the reference value that the binary should have hash of XYZ, and it was wrong actually, and you actually needed ABC for the correct binary, the protocol can never be able to help you in any case. And finally, which was discussed at the BOF as well, time of check to time of use attacks. So that's how we interpreted the comment from the audience. And we believe, and please correct us, Eka, if we are wrong. So what we understood is that the time the evidence is generated, and then the time it is conveyed over to the other party, which is the relying party, you cannot actually provide any guarantee on that. So if it generated, let's say, at point in time T1, and something changed after T1, you cannot provide any guarantee whatsoever on T1 plus X. And only at T1 when the claims were signed, when you convey it over, that conveyance cap can never be fulfilled. That's just time of to check to time of use, the time at which the evidence was generated, time of check, to the time of use at which the other party actually appraised that evidence or checked that evidence. Yes, please. Eka?
Yeah, I mean, I don't really think this is actually that accurate a characterization of the point I was trying to make. Which is about like that if you can't guarantee the future state of the keys, then none of this does any good. So if you really think it's out of scope, I understand the point of the operation. So, so I think the point was, so I think what we're debating, as I understood it, was whether or not the binaries could be updated after the proof was generated. And if you can't preclude that, I don't understand how this works. So, and the way you preclude it is by having the proof cover some assertion the binaries won't be updated.
Right. Okay, so from the threat model, we can have the security goals, which are based on this threat model, specifically what we want to achieve with this. And as I said, so we have that abstract material from that. It's from RATS coming, what the guarantees are. Standard TLS properties such as the server authentication, they should hold in any case. And remote attestation properties, we have tried to represent them what we actually want, meaning that integrity of the claims, whatever these claims are and how these are interpreted is a different story. So we want that whatever the claims were put in by the evidence, the integrity is maintained. They cannot be changed by the attacker. And freshness, that they are kept fresh. It's not an older evidence that is provided to the relying party. And then attestation credential refresh, which is on the lines of, if at a point in time I have this attestation evidence, what happens afterwards? The channel is established, and that runtime integrity is the property which is covered by the refresh of the attestation credentials, which means that I can have, after the session is established at any point in time for long-lived connections, what is the status at any point in time, and how we achieve it, I will show later on. With these two ingredient goals from TLS, from remote attestation, what are the composition goals? How do we combine them together? That's the idea which I'm showing here, which is namely the binding of remote attestation to TLS protocol, which is that I want to ensure that the evidence which is used is bound to this specific session, and it cannot be used in any other possible session, even if the server as attester was malicious. So even then it cannot use this evidence in any other session with any other client, which is a very strong guarantee that we believe that could reduce much of the attack surface. And then finally, the evidence is generated by the same server that is authenticated. That's the kind of binding we need to ensure that the status that I'm checking or the state that I'm checking is coming from the same identity of the entity that I am talking to or establishing the connection. So with that, I want to go to how we plan to achieve that, or what our initial proposal is, that is exported authenticators. Was already mentioned by Thiru in one of the talks now. And just a quick recap. So client certificate request is just similar to the certificate request which the server sends in standard TLS, that's defined already in 9261. And the authenticator keys are really the binding which is provided by the underlying TLS session to the exported to the application layer, so that they are really talking to the same session and not a new one or a different one. Okay, so the client, the idea of authenticator request, exported authenticators is that it has the authenticator request which contains this client certificate request, and the authenticator is then generated based on which contains 3 messages: certificate, certificate verify, and finish, just like the way they are in the original one, original RFC, I mean 8446. The difference here is with the bindings, and that defines new exporters. On top of that, how we utilize it, or how we propose to utilize in our initial proposal, is that in the client certificate request, we can put in the attestation nonce, and the certificate will, in addition to the X509 certificate for identity, it will also contain the attestation evidence. So we just extend the post-handshake part of the protocol, the original TLS protocol remains exactly the same. And with that, I have the protocol diagram for the post-handshake flow, what happens after the standard TLS has been established between the two entities, and step by step showing what is going on. Authenticator request, which contains this certificate request context, that should be unique within the connection. The second one is, the second step would be that the server as an attester here would generate the evidence, and this evidence will contain the nonce as well as the exported keying material from the session, which will bind it to this evidence to this specific session, and so it cannot be misused. And the post handshake certificate message, again, as a reminder, we are talking about post handshake. So this certificate message is the post handshake message, and evidence will be extended. The certificate message will be extended with this evidence, and then we will send over the certificate verify message, and that will be exactly as it is in RFC 9261, and finished message also exactly as in RFC 9261. The only thing that will be added at the end of the solution is the validation part, that it will still appraise that it will still check that X509 certificate, but in addition, it will appraise the evidence which was sent over. So this and this, I mean, identity and state will both be checked, and the end condition will actually ensure that if one of the things fail, the whole system does not fail. So it can still fail one of the checks, and it will not be sending over the secret data over to the entity. That's pretty much it. So any questions or thoughts about this?
All right. I think we probably need to move on to the next presentation.
Okay, so this is a very short presentation on what I just presented. I have this draft for the extensions to the FAT process, which is basically saying that there is an asymmetry of how many people we have developing the protocols versus how many people we have doing the formal verification. And that's in addition to that, there is a steep learning curve for formal method tools, which is namely that in order to get to a stage where you can actually verify some useful properties, there is a lot of gap between the two. And I forgot my third point.
Sorry, apologies, something happened.
Okay, and that is the sustainability of the FAT process, namely that we have a very nice process, which is the FAT process, which is leading us to develop nice specifications, which can be formally verified. And we do have then the formal verification, analysis for some of the drafts. But what we need to think about also is the sustainability part, that how do we proceed with this symmetry, this asymmetry, I'm sorry, and the steep learning curve about this. And the necessary components, as I just presented in the presentation before, so we think of it as three components, meaning that the threat model, what is the threat model for the draft? It should be a part of the draft itself, and informal security goals, as well as the protocol diagram, the concept of which is the same as the protocol model in RFC 4101. And the key idea that I want to emphasize here before I go to you, Eka, so to this point is that I propose it should be done at some level of abstraction, at least before we go for adoption of the drafts, meaning that at least some level of threat model exists, some informal security goals are there, and some form of protocol diagram is there at some high level conceptual view. And another point that I want to make is that in the draft I wrote, it should be a separate section, but I want to say that I'm not specifically attached to that. Actually, my initial proposal was to have it anywhere in the draft. Actually, that's very suitable for implementers. They really need to know what are the security properties that are provided by a specific draft, and that should the point I really want to emphasize it that it should be a part of the draft itself. Where it falls at, that doesn't matter. Yes, please.
Yeah, I mean, I found this awfully prescriptive, really unnecessarily prescriptive. I mean, first of all, I don't understand why. I mean, protocol diagrams I think are great. I'm the author of 4101, but I don't think you always need them. I think you know, if I'm adding a new thing to an existing message, I'm not sure what the protocol diagrams bring to the party. You know, like I don't understand why this stuff, why these are gates to adoption. They seem like gates to formal analysis. So I guess I think, you know, if you, I guess I would put that if you want to put this in the wiki and say like these are like good things, and if someone and they want to go on the fat thing is like if you don't have something like this, you're gonna have some problems. I think that's fine, but trying to turn this into some kind of like actual set of process that we have to follow, I think is unfortunate. Would be unfortunate.
Okay.
Watson.
Hello. I think that I understand the goals and I'm supportive of that. I don't think the solution is to have every draft incorporating the same boilerplate about the goals and threat model when those are largely shared across TLS. I think it would be better for a draft to focus on them. I also don't think that I don't think the adoption process should force people to get the draft too far along. Like, we are supposed to be able to change these things after adoption and weigh in on them. And the more we put to the adoption process, the bigger the burden is just for bringing the idea in. And I don't think that's how we want it to work.
Right, just a quick clarification. I wrote it in the draft that this is only applicable to those which are non-trivial extensions. I forgot to mention it here, but I definitely mean that is for non-trivial extensions of the TLS, not for all drafts of TLS.
All right, Deirdre, you get the last word on this one.
Yeah, just wanted to point out what we currently have written down for the FAT process, which is we ask FAT their opinion if they think they need to look further at a proposed change. They bring that recommendation to the working group, and the working group comes to consensus about whether to take that recommendation or not. So the proposal, I like all these ideas. I think any document that comes to the working group with, you know, protocol diagrams and formal formal definitions of the properties they're trying to achieve are excellent, and I like them, but making them a requirement for adoption is a bit of a burden. And also the way we've currently structured FAT is basically it's all advice and recommendation that the working group gets to decide if they take it or leave it. And they can leave it if they want. So.
Sure, thank you.
All right, hey, we got one last presentation. Nick has 5 slides. We're gonna probably run over. Hopefully you're all right missing the snack break for a couple of minutes.
I'll go pretty quickly. We'll try. So this is sort of a follow-up from last time, which is ECH. We're all happy it's going to be RFC soon. Yay. One of the biggest challenges that we had in ECH is when the keys are out of sync between the client and the server. And while exploring that, we found that it's sort of an awkward mechanism for updating this ECH config. So currently there's only 2 ways of updating an out-of-date ECH config, you know, requerying DNS or inside of a TLS connection where the public name is the trusted name. This is officially listed. So what I'm proposing here, and this is after a bunch of discussions last time, is a way to make it easier for clients to obtain updated ECH configs without limiting some of the difficult things that come along with trying to use a certificate that covers the public name. So there's been a number of previous discussions about this. From the Masquerade draft, from implicit ECH, which I presented last time, and even earlier about DNSSEC. But the idea here, the proposed solution, is that you'd have a way to take the ECH configuration, which lives in the HTTPS record, and sign it. Rather than having an unsigned object, you'd have a signed object. And this signed object could be distributed to clients no matter what the TLS handshake is used. It It could be distributed in the .well known. It could be distributed in a lot of different ways. Currently, the update being tied to the rejection it's just messy. It causes some issues with deploying different client strategies. So there are 3 potential trust mechanisms that we came up with. This discussion is mostly happening on GitHub on the implicit ECH draft, but broad strokes, there's kind of 3 ways of doing this. One is like a DNSSEC signature. One is a certificate that's tied to a signature that's tied to a trusted certificate that covers the appropriate name. And the last one here is a public key that is embedded in the very first ECH config you get. So if the first ECH comes, you can have a key that says any update that is signed with this key, you can use to replace me. And so with that, that's the main idea. So I want to gauge the interest of the crowd of doing more work for ECH, and especially in this direction.
Sorry, let me unlock the queue. Ecker.
Thanks, Nick. This seems like an interesting idea, and certainly we have a real problem with ECH authenticity, so I'm glad to see people working it. One thing that's not quite clear to me, and maybe I just wasn't paying quite close attention, is so in the retry flow case where things fail, right? I connect to you and you've lost all the keys, right? How do you deliver the signed ECH to me? You just like what? Can you just walk me through that flow a little bit? Because I think I've lost the plot.
Sorry, I didn't catch. How do you do what, Ecker?
So the case that the case that the retry flow is intended for, right? Where I have a stale config and you've lost the keys for it, right? So what happens? I mean, so we assume the thing is signed, so everything's great. How do you actually deliver the signed ECH to me in this context when I connect to you and I've got the wrong key?
Right. Okay. So you connect to the server, and then the server responds with a certificate that covers whatever the outer SNI is, and it is rejecting ECH in that case. There'd be an extension that has a blob of data, which is, here's your fresh ECH key, and that's a signed object. And the client would consume it, verify the signature, and then retry the ECH connection.
Okay, so this retains the requirement of the public name match, but it's a backup mechanism, or it displaces the public name match?
This would be in addition to the public name match.
Great, thank you for the explanation.
Or replace it.
Stephen Farrell, yeah, so I think this is worth looking at. I'd be a bit concerned about the different, who's signing, unless it's the case. Well, yeah, actually, I'd be a bit concerned about who's signing, because there's a bunch of ways of making things harder. Because when you generate the ECH key pair, you might not have access to the relevant private key, and depending on who we assume is supposed to do the signing part, then that could all just get hard to deploy. So I think it's tricky.
I think one of the good things about this is that these ECH configs can be signed offline. They don't have to be signed live. So you can sign them, distribute them out to the edge, and send them to clients without needing access to this key. So the keys for signing this could be even a long-term key. It could even be held in an offline place like an HSM.
Sure, but I think in a bunch of deployments, the place where you might want to generate the ECH key might not be where the private key typically is available. And you might this might involve changing a bunch of kind of workflows, and that gets tricky. So for example, if
yes, no, I understand. So what this actually looks like for signatures is up for debate. I mean, this is relying on an existing PKI or TOFU. Those are the 2 options. Ben?
Hey, so, yeah, I think I still don't really understand the threat modeling that drives a lot of this. You mentioned some operational concerns about the recovery flow. Yeah, I also don't really understand those either. So I definitely it would help to have some very detailed explanation of like why the current thing is not sufficient. I do think that a lot of the discussions about this have either fallen foul of assuming that the server has lost one of its keys, but that we can solve that by adding a new key that it doesn't lose, when there's no real understanding of why it wouldn't potentially also have lost that other key. And for the implicit ECH benefits, I think that what I feel is missing there is the game theory of trying to walk through why it actually would ultimately help the client to be able to select a different SNI, outer SNI.
Thanks. We'll write it up.
Yeah. So Martin Thompson, to address part of Ben's comment, the life cycle in this key can be different from the life cycle on the other key. They can also be roughly equivalent in duration, which is kind of interesting about this one. Another thing to observe here is that in the present ECH design, your ECH config expires, but one piece of it never expires, which is the public name. And that public name comes from the DNS. So effectively, we do have tofu in a sense because whoever controls the DNS chooses the name, and there's nothing that ties that public name to anything in the reference identity other than the DNS record itself. And so anyone who has access to the DNS can pick whichever name is then authoritative for producing ECH configs in the future. And this is like part of the threat model of ECH anyway, so that's not really a big deal. So I'm kind of in the tofu camp for this one. I think there's things we can do to strengthen this with DNSSEC or various other things to prevent, for instance, recursive resolvers doing funny things with it. But I like this general direction. I like the idea of being able to have something that's a little more robust in terms of updating, even if it requires signatures. But that's fine.
Thanks.
Alessandro Gaddini, Cloudflare. So just to say, I'm positive as discussing this further. Obviously, we need to land on a specific design and fine tune it, but I think we should continue discussing this.
Great, thanks.
Okay, thanks. That wraps up our session. But just remember, thanks. Thanks for the lively discussions today. Please make sure to chime in the SLH DSA adoption call and the adoption call for the PAKE draft and we got another thing coming on. It's going to happen tomorrow. So before you disappear on vacation. Thank you very much. I gotta get people slides before. You got 12 slides. You got 15 minutes. Not my hope is that they can be like, all right, see. It's kind of different.